Welcome to Spring LIB.
This problem we have been given blocks A and B. So this is A and this is B, and we have also been given that the weight of this block B is 711 Newton. So we'll represent the forces in the diagram here only, and the coefficient of friction between the table and the block is 0.25. So here we need to first draw the free body diagram of both these objects. So first, talking about this object B. So on B there will be a tension force to the right, and there will be a normal reaction force. There will be weight which is acting in the downward direction, and there will be a friction force which will be mu times the normal reaction. Talking about the free body diagram of A, so the only force acting on A will be the tension force and the weight of this A. So that was the first part, and now we need to figure out the tension force as well as the mass of this body A. So here we observe that at this point basically, let's say this is B, so this is given out to be in equilibrium. So considering the equilibrium of the object, we will figure out the mass and the tension. So for that, let's represent the forces here. So there will be T, there will be weight after A, that's W, there will be friction force. So the normal reaction force, that will be 711 newtons only, because there is no such accelerations or movement along the vertical direction, and the friction force will be 0.25 times 711, that's 177.75. So 177.75, that's the friction force. So here we can say that the tension at this part, let's take this tension as T1 and this tension as T2. So T1 will be equal to 177.75 newtons. And now let's say here we have another tension, that is T3, and here we have been given that this angle is 30 degree, so we can just project this T3. So this will be T3 cos 30, that will be root 3 by 2, and along this it will be T3 sine 30, that will be T3 by 2. So basically along the horizontal direction, we can say that T3 root 3 by 2, that will be equal to T1, and from here we can get this T3, so that will be 177.7 times 2 by root 3. So when we multiply this 177.75 with 2 and divide it by root 3, we get the tension here as 205.3 newtons. And now we can similarly get the tension in the vertical direction once we have got this T3. So basically T3 by 2, that will be equal to T2. And from here we can see that T2 will be 205.3 divided by 2. So this gives us finally the value for T2 as 102.5 newtons approximately. And this will be equal to the weight. And from here we can compute the mass of this block A. So that mass will be weight divided by the acceleration due to gravity. So that's 102.5 divided by 9.81, and this will come out to be in kilograms. So 102.5, when we divide it by 9.81, we get the mass here as 10.5 kilograms.